Good day to our lecturer, Professor IR Dr. Kenneth. So this presentation is for our assignment for subject BENT 4733 Digital Signal Processing. So for this assignment, we was assigned to do digital filtering of audio signal. So we was given a list of audio signal and we chose one of the audio in the format of WAV, which is included with noise. So the objective of this assignment is going to be we filtering the noise signal. So I will explain the introduction. Okay, so filtering is actually a technique for decreasing noise in a signal by blocking the frequencies. So a filter works by attenuating certain frequencies in a signal while allowing the others to flow through with negligible attenuation. And it is also important to note that this method of noise removal necessitates the noise having a different frequency domain description than the other signal of interest. In this assignment, we have particularly used two main types of filter, which is the time domain for FIR and IIR filters, and frequency domain is the FFT filter. So I'll be explaining for the first type of time domain filter, which is the finite impulse response FIR filter. So the first one will be the finite impulse response FIR filter. So the FIR filter is a form of digital filter and it generates a dynamic system's limited impulse response. To put it another way, the filter's impulse response has a finite time in this case, and the response of FIR filter is fixed to zero in a finite amount of time, and hence the name. The nth order filter creates n plus 1 samples before being fixed to zero in the case of FIR filters. Because the FIR filter lack feedback, they can only work on current and previous input values. So as a result, the input is a sum of a finite number of finite samples of input values. As a result, these are quite stable. So for the next part, which is the IIR filter, I'll be passing to my one of my group member to present.
Thank you, Malini. Infinite impulse response IR filter. IR filters can be more sensitive to numeric word length and implementation approach because of the feedback. By modifying the numeric word length of the coefficient in the filter design application, you may examine filter functionality. The filter coefficients are also displayed in stages by the filter design application. According to the equation below, each stage has the corresponding A and B coefficients, making stage programming straightforward. The numeric word length is substantially less susceptible to IIR filters that are implemented in phases. In this assignment, we choose the IIR because it has low pass and anti-aliasing filtering application in digital filters. The magnitude response of Butterworth filters is maximum flat in the passband and monotonic overall. The smoothness comes at the expense of the steepness of the roll-off. For a given filter order, elliptic and Chebyshev filters provide steeper roll-off. Thirdly, fast Fourier transformation. The fast Fourier transform is mathematical approach for computing the discrete Fourier transform of a sequence. The main difference between FT and FFT is that FT considers a continuous signal as input, whereas FFT examines a discrete signal. DFT converts a sequence into its frequency constituents in the same way as FT converts a continuous signal into its frequency continuance. The signal is translated from the time range into the frequency range, where noise reduction is performed by editing the amplitude values, and then the signal is transformed back into the time range. The volume of the entire audio that was assigned is first specified. This is a block by block procedure. The average volume of each block determined. It keeps track of the average block volumes minimum and maximum to eliminate errors induced by artificial quiet. Blocks having an average volume of less than 10 digits must be excluded. Also calculated is the average of all block volume minimum values. Objective for this assignment is to identify unwanted noisy signals and to eliminate them using FIR or IIR digital filters. Second objective is to, to identify unwanted noisy signals and to eliminate them using FFT based filtering method. The equipment that we use for this assignment is computer and MATLAB software. Thank you, and I will pass this to one Irne Aida.
Okay, thank you, Ranggita. And now I will continue with the procedure and then I will show how the result is. First, the procedure is the code for audio read was inserted to get the value of signal frequency. F and sampling frequency, Fs is for unfiltered audio. The value for F and Fs was utilized to filter the audio. Next, the value for carrier frequency was changed according to desired value to obtain the filtered audio signal. And then 4 is the MATLAB function was generated to obtain the original time domain and amplitude frequency spectrum. After that, bot plot function was plotted to show the plot of filtered signal. Then the low pass IIR Butterworth was used to filter the audio signal with the function of BA equals to Butterworth NWN. And then spectrogram function was used to view and analyze the corrupted signal and the filtered signal. Last, the zeros and poles function was generated to show the stability of filtered signal. So I will share my screen. See, this is the coding for the MATLAB. This is the coding where we put our original audio. And then this is the original audio coding where we can get the original time domain and original amplitude spectrum. I will play to you the original audio first. Okay. As you can hear, that is the audio for the original and it had a noise. Next, moving on to the filtered audio, this is where we got the bot plot, and then this is the spectrogram for original for filtered audio. And then this is the spectrogram for unfiltered audio. And then we got the pole plot or zeros and poles. So I will play the after filtered audio. As you can hear, the noise already been reduced, and then we have achieved our objective. And then next, I will pass it to my friend Lin Ming Mei.
Thank you, Wan Ernie. In conclusion, the both goal of the assignment was achieved. The primary objective is to identify unwanted noisy signal and to eliminate them using FIR or IR digital filter. We are choosing IR digital filter because it is for low pass and anti-aliasing filter applications. We learned about how to insert the code for audio read in the MATLAB to get the value of signal frequency and sampling frequency. Then we also able to generate the MATLAB function to obtain the original time domain and amplitude frequency of spectrum. The second objective is to identify unwanted noisy signal and to eliminate them using FFT-based filtering method. Then we compare the spectrum unfiltered and filtered signal. Finally, the assignment can be complete with all the understanding of the FIR, IIR, and FFT filtered. That's all from us. Thank you.